In this video, we're going to solve the same circuit yet again, this time using superposition. So we have two independent sources in our problem, which means we're going to need to turn one on and one off, solve the circuit, then switch which one is on and off, and solve it again. I will start by making the 2 amp source on, which means the 6 volt source is off. So I go ahead and redraw my circuit here. We have my current source, 2 amps. My voltage source is gone, which means you want a voltage of 0. A voltage of 0 is a short, so we have a short here. We have 1 ohm. We have the I0 that we're looking for. And then here we have our resistor that's 1 ohm and our capacitor that is minus J. So what I can go ahead and do here is I can do some combinations of impedances that are in series. I have a 1 plus J for this left branch, and then I have the 1 ohm that we're looking for the current through. And then the right branch, I have 2 impedances in series. That's going to be a 1 minus J. Now all 4 things here are in parallel, so what I'm going to do is I'm going to combine the 1 plus J and the 1 minus J into a single impedance using the parallel rules. And so we need to have, 1 plus J times 1 minus J over 1 plus J plus 1 minus J. On top, you're going to get 1 minus J plus J cancels out. Minus J squared is 2. On the bottom, you're going to have the J and minus J cancel and you get 2. So in fact, 1 plus J and 1 minus J in parallel gets you back to 1 here. So what that means is we are going to have an I0 using current divider as the total current times the impedance we're not at over the sum of the impedances. And this current source is going to give us 1 amp going into I0. Now again, that is not our final I0. That is just the value from the current source here. We need to now repeat using the voltage source. So now we're going to have the 2 amp source off and the 6 volt source on. If I draw that diagram, I will skip a little bit of work here and combine the impedances that are in series. For the current source, a current source with a value of 0 means there's no current, which means it isn't open there. So we go ahead and replace that there. And then we get 1 minus J. And what I'm actually going to do here, I think the easiest way to do this is to perform a source transformation with the 6 volt source and the 1 plus J. So it's now going to be a current source whose value is 6 over 1 plus J in parallel with the source 1 plus J. This will do 2 things. One is we can now combine the 1 plus J and 1 minus J in parallel like we did earlier. And then we'll also be able to use current divider again. So writing this out here, we have 6 over 1 plus J. And we have the 1 ohm where the I0 is going through. And then we have the other 1 ohm that is and it's really not a resistor here. I put a box, so this is just a combination of different elements, and it's going to become a 1 ohm, like in the last one. So this time I0 is the total current, 6 over 1 plus J, times the impedance we're at over the sum of the impedances. This is going to be 6 over 2 plus 2J. This means then, now that we've solved it with both sources, we can find the total response by adding them up. So I would have I0 is the first 1 amp from the original source plus the 6 over 2 plus 2J here. Again, I could try doing the hard work myself and writing it out, or we can just use our calculator. 1 plus 6 divided by 2 plus 2J. And we're going to get 2.5 minus 1.5J. And so now that we have our I0 in terms of phasor, we can go ahead and convert it to polar form here. And that's going to give me a 2.91 angle negative 30.9 degrees. So that means our final answer, as we saw before, is I0 of t is 2.91 cosine, still don't know omega t, minus 30.9 degrees in terms of amps. And there we have it.